Hello everybody, I welcome you back in this course Introduction to Sequence Stratigraphy, and we will continue our discussion from our previous class where we were discussing on the cyclicity in sedimentary succession. So, already we have seen that there can be different types of cyclicity. The types of cyclicity can vary depending on the amount of time involved in terms of repetitions of the events, and it can vary on the resultant products in terms of their vertical thicknesses in a sedimentary succession. So, in this class we will try to understand about these different types of cyclicities. Basically, we will call it as the hierarchical subdivision of the cycles, where we will try to divide the stratigraphic successions into several cycles based on the time involved over there. So, the first type of cyclicity is called as the first order. So, what is the first order cyclicity? In terms of the time interval, it will be around 200 to 400 million year time involved. So, it is a very large time involved over there, 200 to 400 millions of years. So, definitely these are some mega events on the earth, and certainly such mega events should be controlled by or can be controlled by some major scale processes like the plate tectonics. So, definitely the reason for formation of this kind of cyclicities, the first order cyclicities, are commonly the tectonics. So, when you are talking about tectonics, mostly the formation or breakup of the supercontinents. So, that plays the most important role in the formation of very large scale cyclicities, which we call as the first order cyclicity. So, in terms of the thickness of sedimentary successions, it can be in terms of thousands of meter, which can vary from area to area, from basin to basin. So, instead of going into the thickness part, we rather concentrate on the time interval, and commonly the formation or breakup of supercontinents, that kind of tectonic changes, are associated in terms of 200 to 400 million year. Such kind of tectonic activities, when formation or breakup of supercontinents are going on, they are also commonly associated with some global scale sea level changes, which commonly we call as eustatic changes. So, along with such major tectonic events, accompanied with that, we can get eustatic cycles, eustatic sea level changes, which controls the formation of such thick succession in this 200 to 400 million year time scale. The next one is the second order cycles. This kind of cycles are often called as super cycles. Super cycles. And originally, the concept of sequence stratigraphy, the definition of sequence, was derived from this order, these second order cycles, the concept of sequence in sequence stratigraphy. So, what is the time interval for the second order cyclicities? It can be around 10 to 100 million year time. So, 10 to 100 million year time, and during that time interval the succession developed or the events repeating within this time scale will produce second order cyclicities. So, what are the reasons? Again, the tectonics and corresponding eustatic control. So, again the formation and breakup of the supercontinents, maybe the seafloor spreading, and whenever such tectonic changes are occurring, the corresponding eustatic changes, the corresponding sea level changes occurring across the globe will affect the basin scale successions. So, tectonics and eustacy again. Next comes the third order cyclicities. So, these third order cyclicities are relatively of smaller time duration. So, the time duration involved over here for third order cyclicities are commonly 1 to 10 million year. They are often called as mesotherm or they are often called as mega cyclothem. As the time involved over here is much less, 1 to 10 million year, so definitely the processes involved over here are of relatively smaller scale with respect to the earlier second order or first order cyclicities. So, what are the possible causes? Number 1 can be glacioeustasy, and along with that is glacioisostasy. That means the melting or formation of large ice sheets, which can be controlled by climatic changes very commonly, and that can produce wide scale glaciation across the globe, like the sheet glaciers, like what we see today in the Antarctica. And formation of such glaciers will definitely produce change in the global sea level, or the melting of those glaciers will produce change in the global sea level, as well as due to that huge load of the glaciers which is lying on the continental plates will produce some sort of isostatic adjustment. Reverse kind of adjustment will happen when that glacier will melt and that load is removed. So, glacioisostasy and glacioeustasy are the primary controls for the formation of third order cyclicities, along with some minor scale tectonic or eustatic changes. So, local scale tectonics and associated sea level fluctuations can also produce some sort of cyclicities, but definitely of smaller extent, and their time duration is much smaller in terms of 1 to 10 million year. Coming to the next one, which is the fourth order cyclicity. Fourth order cyclicity, their time range is around 0.2 to 0.5 million year. So, these are commonly called as the cyclothem, which commonly indicates Milankovitch glacioeustatic cycles. What is this Milankovitch glacioeustatic cycle? We will discuss after few minutes. So, basically what we get in fourth order cyclicity, the successions formed due to dominantly climatic changes. Climate related controls and fluctuations results in large scale or long term seasonal changes, and that kind of changeover can produce cyclicities within the succession, because that kind of changes in the climate will produce or affect the sea level conditions, and that will in turn affect the sedimentary succession, producing different types of cyclicities. So, the fourth order cyclicity are one kind of Milankovitch glacioeustatic cycles, also called as cyclothem, and these are the smaller units within sequence. As in second order, we have said that these are the basic definition of sequence. Sequence stratigraphy, when it started, the definition of sequence was based on second order cyclicities. So, as we are coming down to third order or fourth order, we are coming down to further smaller units within sequence stratigraphy, and finally we can have the fifth order cyclicities. The fifth order cyclicities, their durations are around 0.01 to 0.2 million year, 0.01 to 0.2 million year, and again they are the result of Milankovitch glacioeustatic cycles. So, fifth order cyclicities, definitely they are also the result of short scale climatic changes, and such short scale climatic changes produces smaller extent of sea level fluctuations, and due to those fluctuations we can get cyclicities of time duration this much. So, definitely these are much smaller cyclicities. So, very often this kind of cyclicities can be correlated with the parasequences. As earlier we have discussed about parasequence concept, not in detail, but some basic idea about parasequence during our definitions. So, this can be, this fifth order cyclicities can be defined as equivalent to the parasequences. Apart from all these 5 divisions, which are the standard definitions, standard cyclicities, there can be further subdivisions like the 6th order cyclicities where the time duration is much smaller. So, there the time interval may be even less than 0.01 million year, ranging into the thousands of years. So, all these cyclicities, all these classifications, they are classified based on one major factor: how much is the control going on in terms of time duration, and the cyclicity is controlled by dominantly the sea level fluctuation. So, always there has been a trend or practice that we try to reconstruct the sea level curve for each of these cyclicities. So, there are some standard sea level curves. For example, this sea level curve comprising the entire Phanerozoic. So, this curve indicates the first order cyclicity. When we look into little bit further zoom in, we can come to the second order cyclicities, and this is the second order sea level curve indicating the second order cycles during the same period. So, here you can see this is one cycle. Say for example, for the first order cycle, this is a falling condition. That means across the globe during this particular phase, that is the end of Paleozoic to Mesozoic, middle of Mesozoic, we get overall lower sea level condition. But when we come to the second order cyclicities, within that first order major fall, we can see there are minor rises, minor rise in the sea level conditions in between that major fall. So, the overall sea level is remaining in a lower condition, but within that lower sea level condition, there are certain phases when sea level was little bit higher or significantly higher, and again it has come down. So, that kind of cyclic changes in the sea level that we can record over here will definitely produce its characteristic sedimentary succession. Those successions, those characteristics within the sedimentary successions cannot be recorded from here. In the same way, if you look at over here, this part, the second order cyclicity over here in the Cenozoic, which is enlarged in this part. So, now you can see how many fluctuations are there, as you can see over here, so many fluctuations in terms of sea level curve. So, when we are going into third order, the cyclicities, their durations are much smaller in terms of 5 to 10 millions of years, whereas when you are looking into second order, such cyclicities are ranging in terms of 10 to 100 millions of years. When we are looking into first order, they are in terms of hundreds of millions of years. So, definitely the cyclicity occurring over here in this part, in the third order, will produce much smaller scale fluctuations in the sedimentary cycle, and their thicknesses will be much smaller with respect to the sediment thickness formed over here within the first order cyclicity. So, these are some standard global sea level cycles. However, locally from basin to basin, the sea level fluctuation can be completely different. Due to some local changes, there can be some local sea level fall condition. As you can see over here, if you just correspond this particular zone, here it is a rising condition in terms of first order cyclicity, but if you look at over here in the second order, there is a very sharp fall in the sea level that we can record in second order, but not in the first order. So, this kind of fluctuation that we are recording over here in the second order will definitely have a mark on the sedimentary succession, and accordingly we get different orders of cyclicities. As in the previous class, I gave you the example with that multiple types of cyclicities in different scales. So, cyclicities can have their own characteristic durations, and based on that durations, they can have their own characteristic sedimentary successions. Third order cycles are commonly recognized in the normal field exposures, as well as they can be very well recognized, identified in the subsurface well records and the seismic reflection profiles. When we move on to the first order or second order, they are commonly identified in seismic reflection profiles or maybe in very large scale well records. Third order cyclicities ranging from 1 to 10 million year are commonly attributed to the fluctuations in the eustatic sea level owing to changes in the spreading ridges and the continental ice growth and decay, which results in glacio-isostatic and glacio-eustatic changes. Now, if we look into the further smaller scale cycles, fourth order cycles, and fifth order cycles, etc., they are in terms of bed scale cycles or maybe meter scale cycles, and they are spanning in terms of 0.2 to 0.5 million year or less than that. So, commonly these kind of cyclicities are related to or attributed to changes in the Earth's orbital parameters. What are these factors? When Earth is rotating around the Sun and Earth is rotating on its own axis, certain changes occurred during that rotation, and those parameters have a very significant effect on controlling the Earth's climatic condition. What are those factors? Number one is the obliquity. What is obliquity? Obliquity is the tilt of the Earth axis. If we draw the Earth, it is not straight like this, rather it is already tilted, and this amount of tilt can further vary. For some time the axis is like this, for some time the axis is like this. So, this amount of variation can vary a little bit. How much? Say around 21.5 degree to 24.4 degree. It can vary in between that. So, that much of variation in the tilt of the Earth's axis can produce change in the Earth's climatic condition, and that change in the climatic condition can produce cyclicities in terms of approximately 40,000 years. So, this is one type of Earth's orbital parameter. The second one is called as precession. What is precession? When the Earth is rotating on its axis, it is not on the same plane. The plane of rotation of the Earth's axis, it goes on changing. We commonly call it as the wobbling. So, this wobbling of the Earth's axis, it varies. So, the axis is tilted and the tilt amount is varying, and when it is rotating on that particular position of the axis, it is going through some effect of wobbling, which can produce a variation, a cyclicity in terms of around 20,000 years, to be precise 19 to 23,000 years. And the third one is the eccentricity. It is about the Earth's orbit. So, if this is the Sun and this is the orbit of the Earth, so it is not circular, rather it is elliptical, and the shape of the ellipse varies with time. So, for some time the ellipse can be like this, for some time the ellipse can be like this, and accordingly the position of the Earth at different position of this ellipse will control the distance from the Sun, and the distance from the Sun will control the amount of sun ray, that means the heat amount coming to the Earth, the amount of insolation reaching to the Earth. So, this eccentricity can produce a cyclicity in terms of 100 to 400,000 years. Now, the question arises over here that these three orbital parameters, obliquity, precession and eccentricity, how they are affecting the Earth's climatic condition. The orbital variations produce cyclic variations in the intensity and seasonal distribution of the incoming solar radiation. The incoming solar radiation gets reduced sufficiently to prevent the complete summer melt of the winter snowpack. In the same way, it leads to the build-up of snowpack over and over. If you have a snowpack formed during the winter, it is expected that during the next summer that snowpack will get melted down. But if the summer is not intense that much, what will happen? Some of the snowpack will remain unmelted, and during the next winter on that snowpack, new snowpack will develop. So, such snowpack build-up and subsequent development of the continental glaciers is the resultant factor. Such kind of development of snowpack over and over through seasons will have a long-term effect in terms of drawdown of the water from the earth, from the oceans, because that water body will come into the ice, which will produce lowering of the sea level. And this will have a second effect, that since a large part of the earth gets covered with ice, so lot of sun ray will get reflected back directly. It will become a very shiny surface. So, the Earth's surface will not absorb the heat. As a result, Earth will become cooler as the time will go on. So, the climatic cycles occur with different yet somewhat predictable frequencies, as we have seen in the last slide, that there are certain frequencies in terms of separate orbital parameters. When you are talking about obliquity, that can occur in certain time intervals, or that can produce cyclicity within a certain time frame. Same for precession, same for eccentricity. And we have to remember that these three processes or these three parameters are actually occurring together, and they will have a combined effect on the Earth's climatic condition. The combined effect of these three factors, these three parameters, controls the Earth's average temperature around the polar region to increase or decrease in a cyclical manner. So, alternate warming and cooling of the polar region triggers the melting and growth of glaciers, which modulates the sea level changes, and that sea level change will produce cyclicities within the sedimentary successions. Such climatic controls caused by Earth's orbital parameters and the resultant cyclicities that comes under Milankovitch cycles. Those are termed as Milankovitch cycles, and such Milankovitch astronomical cyclicities influence clastic rocks, carbonate rocks, evaporite rocks and the sedimentation processes, and that effect is actually controlled in three ways: through variations in the continental ice cap volumes, which would cause the eustatic sea level change. Melting of the ice volume will increase the sea level. More formation of the ice will lead to fall in the sea level. Second, by causing the ocean temperature to change sufficiently that ocean water volume would change. And thirdly, by causing the climatic changes in the tropics, so that shallow water carbonate production will change. So, Milankovitch cycles control the major climatic cycles, climatic changes across Earth in geological time. However, those cyclicities are quite less in terms of time extent with respect to the major tectonic and eustatic cycles. So, to summarize, in this particular class, we have tried to learn about the different types of cyclicities. We have tried to classify the cyclicities in terms of first order, second order, third order, fourth order and fifth order with respect to the time interval and the agent or the mechanism which is involved in the formation of those cyclicities. So, with this, I will conclude this discussion on the cyclicity. Thank you, everybody.